Hello, my minions. Through absolutely no fault of my own, my iPad was not at school yesterday, and so now I must record this video today. We're going to look over the 3 warm-ups. The warm-ups each come from Chapter 6, Lessons 2, 3, and 4, so that we're able to look back at them. So we'll look at the first warm-up. It's 96 divided by 4 plus, in parentheses, 25 times 2, end parentheses, minus 15 minus 3. So we're going to start and go over this, and let's see how we do it.
So the one thing that we want to pay attention to, as Rocco so astutely said, is PEMDAS. Now, what does that P stand for, Emerson? Parentheses, and we have some parentheses. So we solve what's inside of it. 25 times 2, Rocco? 50. Excellent. Now we've solved our P in the PEMDAS. What comes next in PEMDAS, Nathan? Exponent. And look at that, we've got an exponent. What is 4 squared? Lucy? 16. So we've solved our exponent as well. Now we got to do this one, and as we remember, multiplication, division, same thing, we just go from left to right. So here, once we've solved these two, we now have 96 divided by 16 plus 50 minus 15 minus 3. So, pretty straightforward. I like to solve as we bring it down. Do we have any multiplication in this problem at all? Yeah, we don't have any multiplication. Oops, that's supposed to be with us. Do we have any division in this problem? Yes, Daniel, what do we need to do? Perfect, we divide 96 by 16, we get 6. Then, because we're super fancy, we have 6 plus 50 minus 15 minus 3. What is the answer to this problem? Who can tell me? Yes. 38, exactly. Great job. So we get 38. There are many opportunities to make mistakes in this. Simply, if you decide to add before you divide, finish your subtraction before you divide, you can do any of that and you'll get it wrong. Yes, Rocco? Rocco's entirely correct. He's getting annoyed at this problem because he says, why does it say minus 15 minus 3? Honestly, it's to trick you. But there's the best part is there's nothing here that it could really trick. What Rocco is noticing is something that we're going to get into even further later, and it's really cool. It's called combining like terms. And we've talked about that once before. Like terms are terms that look the same. So these are both numerical terms. Do they have any variables with them? No, there's no variables. What if I had this term, 2x plus 3x plus 2? Who do you think can give me the answer? 2x plus 3x plus 2. Who do you think can tell me, Hannah? 5x plus 2. Do we have any other ideas? Anybody else have anything else? That's because she's correct. We can only combine the parts that are the same, that both have an X, or that both have a Y, both have a smiley face, both have numbers. And we can even combine it if they've got exponents. Like if we had 2x squared plus 3x squared y. We can't combine those. But if we had 2x squared plus 3x squared, then we could. They have to look exactly the same in the variables in order to combine them. So they have to look exactly the same. Let's look at this next problem here. So we've got b squared minus 5c. This is not a J, this is a semicolon. And it says b is equal to 15 and c is equal to 9. So what do we do here? What do I like to call it, Lucy? What do we do? Oh, you're gonna say the answer? Okay, well first, what do we do? What do we do, Rocco? Excellent. So all we do is plug in. What we're doing is called plug and play. So we get 15 squared minus 5 times 9. Now we're smarty pantses. What is 5 times 9, Elsie? Perfect. 45. And 15 squared. Who can tell me what 15 squared is, Michelle? Perfect. 225. So what do I get as my answer? 225 minus 45, Lucy? 180. Our last warm-up. It's going to be 5 less than 3 times the amount that Daniel complains. So, first of all, what are the keywords? We see 2 keywords in this problem. Anita, give me 1. Less than. When we see less than, what does that mean, Oleg? Subtraction. And where is that subtraction gonna go? Where is that subtraction gonna go? Lucy? Exactly. We see that word than, so it's gonna be subtraction after. It's gonna be subtraction after. Then we've got our second keyword. What's our second keyword? What's our second keyword? I want some new hands, Fernando. Times. And how many times is it? How many times, Rocco? 3 times. Excellent. So we've got 3 times something. 3 times the amount Daniel complains. Do I know how much Daniel complains? It's too much. The answer is too much, but we don't know the exact number, which means that the amount Daniel complains is our unknown. It's our variable. And for all intents and purposes, I'm going to mark it with D for Daniel. So 3 times the amount, 3 times our unknown, 3 times D. And then 5 less than happens afterwards, so minus 5. We see how that's we write the expression? What if I told you this? And I'm going to give you a hard problem here. I want you to solve this problem, but in this case, it's going to be, we're going to solve it equal to 23.
So we have 3 times D minus 5 equals 22.
I want you guys to solve for D. Solve for D. So I made a mistake. I said 24. It should be 22. So 3D minus 5 equals 22. 3D minus 5 is equals 22. What's the first step someone on here took, Hannah? Yeah. Why'd you add 5 to 22? What does that do for us? Exactly. So what she did was she added 5 to both sides. She added 5 to both sides because what you do to one side, you do to the other. And the way that works, what's negative 5 plus 5? Or what's 5 minus 5? What is it? It's 0. So this part, it goes away. It goes away. And then we add it on this side. We would then get 3D equals 27. Now I need to know what times 3 equals 27. What times 3 is 27, Oswaldo? What times 3 is equal to 27? 3 times 9. So we know that D has to be 9. One of the ways that we solve this is we isolated our variable. What times 9 equals 27? What times 9 equals 27, Hannah? Exactly, 3. So we have what we're calling our fact families. We have our fact families. We got 3 times 9 equals 27. 9 times 3 equals 27. As I'm writing the wrong thing. 27 divided by 9 equals 3. And 27 divided by 3 equals 9. Right there. That's our fact family. That's our fact family. The reason that it's important is because, look, I have 3 times something equals 27. That's following the 3 times 9 equals 27. how I would solve is I would actually just divide them both by 3 to get D alone. What's 3 divided by 3? What's 3 divided by 3, Lucy? 1. So those go away and I'm just left with 1D. What is 27 divided by 3? Looking at our fact family, Anita? 9. So that's how we can use our fact family and isolating variables, just like we do the opposite. So Hannah subtracted, or she added 5 to each side because we had a -5. Here we have a multiply by 3, so we divide by 3. This fact family nicely leads into our lesson for today, which is learning about 4 properties that we're going to be doing. In your book, under Chapter 6, Lesson 5, Properties, you are going to write these down. So when we look at this problem, in parentheses, 20 minus 12, we're learning about the distributive property. So essentially, we're just learning about 4 properties. Now, if we're looking at page 485, we see this problem. 3 friends went to a baseball game. Each ticket cost $20, and all 3 friends bought baseball hat for $15 each. What does the 3 represent in this formula? Michelle? Exactly, it's the total of friends or people. We could say that, it's how many people went. What does the 20 represent? Lucy? Yeah, it's the ticket cost. So it's the ticket cost for each of them. And what does the 15 represent? What does the 15 represent? Rocco? Yeah. Price of the hat. Now, here's where we would need to do this together. We're checking this, and it's showing us how our properties will be useful. Now, what is 20 plus 15? What is 20 plus 15? Easy math right here, Anita. It's 35. Now I've got a question for you. What does that 35 mean? What does that 35 mean, Lucy? It's the total cost of 1 hat and 1 ticket. Exactly. But is that how much they paid? Why is that not how much they paid, Rocco? It's each. It's each. So we have to multiply that price for 1 baseball hat and 1 ticket for the amount of 3 people. So for the amount of 3 people. What is 35 times 3, Daniel? Perfect. 105. Excellent. Let's look at the second one. What does the expression 3 times 20 plus 3 times 15 represent? What does that expression mean? What is it saying in human words, Lucy? All the friends buying a ticket, and then all the friends buying a hat. We have 3 times 20. That's 3 times the cost of 1 ticket, so 3 tickets. Then we're adding 3 times 15, 3 times the amount of the cost of a baseball hat. So that's how we're doing these. That's how we express them. Now, the thing is, we're gonna get the same answer each time. Do you notice? When we do it one way, it means the same thing. What's 3 times 20? 3 times 20, I see all my same hands, Hannah. What is the answer? 60. Excellent, Glory. What is 3 times 15? 45. We get 60 plus 45 is 105. So we had the same answer for both of these 2 problems. One of the properties, the last property we're learning, is the property. So the distributive property essentially means that we pulled out a common factor. We pulled out that common factor. Essentially, all we're doing is doing the same thing. We're factoring. All we're doing is we're factoring. So right here on the board, what I did is I factored 12 and 8. We have 12 plus 8. What's the greatest common factor of 12 and 8? The greatest common factor, Rocco. 4. Do we see that? Yeah. We see 4. Yeah, we already did this. That's what makes it easier. So when I pull the factors out, when I pull out that 4, it becomes what that other number is across from it. So instead, I'm pulling out my 4, I pulled it outside, and I'm left with 3 plus 2. I want you guys to check this. Are these two the same thing? Are these two, is 4 times parentheses 3 plus 2, is that the same as 12 plus 8?
Spoiler alert, the answer is yes.
What we do is distribute that 4 to each one of those values. When something is touching, what does it mean? You gotta multiply. Here, all we did is we used one of our properties, the property of some sort of addition, to split it into 4 times 3 plus 4 times 2. The way that we write it to make our future math easier is 4 times, in parentheses, 3 plus 2. How do you think I would write it if I had this problem? I'm going to give you the hardest problem. Ready? 5 times, in parentheses, x minus 7. I want you to write out what that answer would be. Now remember, we're just looking for an expression. So we're not looking for a numerical answer, we're just looking for an expression. So what is the simplified expression? Lucy, what do we do? X minus 12. For this one, the bottom one, we can't do that. But look, at the top one, what I do is I distribute everything inside. I distribute it. So it becomes 5 times x and 5 times 7. 5 times x is just 5x. 5 times 7 is 35. My answer literally becomes 5x minus 35. The 35 is 5 times 7.
So your homework is pages 477, numbers 1 through 11, and page 489, numbers 1 through 13.